So welcome everyone to our presentation on fine-tuning techniques for language model or LLMs. So this is a second part in the series. We have a part one where we have the basic concept we cover in a presentation, and if you are interested in that presentation, that's that part of this playlist. So in this rapidly evolving field, understanding the fine tuning is crucial for unlocking the full potential of this all the large language models and tailoring them to specific task and domain, and also to come up with the best solution to adopt what technique to use for the learning purpose in terms of both the efficiency as well as for the cost effectiveness for fine tuning. So we will go through each of them, the different techniques in the next one slide. So fine tuning technique for large language model, let's go through one by one. The first one is in context learning. In context learning involve integrating task example directly into prompt, enabling large language model to handle new tasks without undergoing extensive fine-tuning. By providing clear examples within the input, the model can better understand and perform specific tasks based on the context given. The next method is the supervised fine-tuning (SFT). The supervised fine-tuning update pre-trained LLM with the labeled data to perform specific tasks. This process involves training the model on a curated dataset where inputs are paired with correct output, redefining the model ability to generate accurate response for particular task. So the next one is contrastive learning. Contrastive learning is a fine-tuning method that improve an LLM by teaching to discern similarities and difference within data. By comparing and contrasting data point in the middle model, they learn to better differentiate between various input, enhancing its understanding and the performance. The next one is transfer learning. Transfer learning involve applying pre-trained knowledge from a large dataset to improve LLM performance on a smaller task-specific dataset. This technique leverages the extensive knowledge the model has already acquired, making it more efficient in learning and performing new tasks. So the next one is the reward modeling. The reward modeling focused on designing objective to reward LLM output during the reinforcement learning process by defining clear rewards and penalties. This technique guides the model towards generating desired output, defining its performance based on the feedback. The next one is the reinforcement learning from human feedback called RLHF. This involves using human feedback on rewards or penalties for LLM output. By incorporating human judgment, these techniques ensure that the model learning process align closely with the human expectation and preference. The next one is the parameter efficient fine tuning (PFT). PFT update only a few parameters of the LLM, making it both compute and cost efficient. This techniques allow to targeted improvement without the need to extensive computation resource, making it practical for various application. The next one is the quantization. The quantization reduces the precision of the LLM parameter to save computational resource without sacrificing performance. By lowering the bit width of the numerical representation, model become more efficient in terms of storage and process power. The next one is pruning. Pruning involves trimming surplus connection or parameters in LLM to make them smaller and faster while maintaining performance. This technique helps streamline the model, reducing its complexity and involving rough inference speed. The next one is low rank adaptation, LoRa. LoRa is a PFT method that insert a smaller set of new ways into the model allows specific adaptation without modifying the entire model, making the fine-tuning process more efficient. And then come to the final, we have the freeze tuning. Freeze tuning involve fine-tuning an LLM with most its way frozen, except for some layers, typically task-specific layers. This technique focuses on adjusting only the necessary part of the model, preserving the ongoing tech capability while adapting the new task. Thanks for attending again this session, and the last series on this will be coming up in next week. Stay tuned for that. Thank you.